Welcome back to this lesson. So this is the last part of this domain 3 discussion, agentic AI business solution architect AB-100 domain 3, which deals with deploying AI powered business solutions. I'll be looking at operating, validating, and governing AI business solutions on Dynamics 365, Office 365, and deployment and building on Copilot Studio and Azure AI Foundry. And we just looked at security and risk in our last lesson. Then in this part of the lesson, we'll continue looking at risks and compliance as we round up this part. So if you are just joining us, kindly like and subscribe. All right, so let's look at the first slide we have in this section. So we have AI threat protection. So this is risk. So we are under risk monitoring now. So AI threat protection. How do you protect AI from prompt injection, from this denial of service, and from all the vulnerability of the base model? So we have prompt manipulation, filtering, and red teaming here. And the architecture terms you should understand here are prompt injection, jailbreaks, Azure AI content safety, PII reduction, red teaming. So let's look at the in-depth of what these terms actually mean in the system. So threats in agentic AI system include prompt injection, jailbreaks, data leakage, malicious files, role escalation, SQL injection, autonomous tool misuse. So autonomous system can misuse too, right? Hackers can inject run SQL, language into the system in order to access the data in the system illegally. So you can have role escalation. Agent can, manipulate their role and assume another agent role. You have malicious file. So if malicious file are kept in the in the knowledge source and the agents access it, if another person access your knowledge source and put malicious files there, and agents have access to the malicious file, you can expose the entire agentic AI system operation to to threats. And then we have data leakage. If agent is accessing data that they are not supposed to access, or storing data where they are not supposed to store data, there will be a threat. And then you have jailbreaker. So there's what we call jailbreaker, where an unauthorized person just break and access the application using wrong APIs or wrong endpoints. And then we have prompt injection. So the prompt can be corrupted, and all this hacker can just put a prompt that will cause the agent to do what it's not supposed to do. So these are threats that you should watch out for and that you should prevent against as an architect when you're designing agentic AI system for business solution. Point 2, input filtering, validate file type. So to protect most of this, you can implement input filtering to validate file types, file size, HTML, scripts, prompt injection, and unsafe content. So input filtering can protect against all of this when you implement it correctly as a guardrail. Then the next point we have here is output filtering. So if you applied output filtering to check hallucination, PII, secret, confidential content, toxicity, and unsafe categories, so all this will be stopped. So also implement output filtering to solve any of these threat threat situation or cases. Then use Azure AI content safety to help detect and filter unsafe prompt and outputs. So also use Azure AI content safety as a guardrail to help and detect and filter unsafe prompt and output. Then implement red teaming. So red team before production by attacking the agent tools, connector permission, and data path. So red teaming is just like chaos engineering, where you subject the agent to attack to all these threats to determine the weakness of the agent. And then when you determine the weakness, you correct the weakness by implementing any of these guardrails and then perform it again to test. When the system is perfect and can withstand any of these threats, then you can be sure that the reliability of the agent is 100%. You can never build a system that is perfect, but at least all these threats must be prevented, okay, carefully in your design. Then governance and RAI. So we have governance, vulnerability, responsible AI review. So RAI is responsible AI review. So what are the architecture terms that you should understand here under governance and responsible AI? So understand owner. So who owns the agent? We are working with this business domain. You are working with, and in business domain, you have business owners. So business owners are just like the managers and the workers or employees that are working under the managers. So these people own the agent. So if they own the agent, they should also be responsible for what the agent is doing. Okay. So we have the risk level. How risky is the agent and how risky is the action that the agent is designed to perform? We have approval. So what does agent have access to, and what does he have, what does he not have access to? So are they approved to use it, or was the agent approved by the the Center of Agentic AI Center of Excellence for the agent to be deployed or developed in the first place? So approval is very important. Approval of business owner to use the agent, approval of agent to access database and to operate. Then auditing. So every entire workflow should also be audited. Agents should be audited. What they are accessing, the data they are accessing should be audited. The output they are generating should be audited. All the process, agentic AI process, everything should be audited, whether it complies with the company policy. Then responsible AI usage is part of the architecture. So these are the architecture terms, very important. Let's take them one after the other. Governance defines owner, purpose, risk level, approval, modification rights, deployment authority, audit process, and retirement path. So everything, you can see that the entire agentic AI application lifecycle still passes through governance. And of course, governance is part of the lifecycle management. So governance defines who owns the agent, what was the agent designed for purpose, what is the risk level of the agent, what does the agent have approval to access, how can the agent be modified, or when does it need to be modified, then deployment authority of the agent, audit process, and retirement part of the agent, all defines through governance. Then common AI vulnerabilities include, we have discussed this: prompt injection, data leakage, hallucinations, excessive permission, and autonomous tool abuse. So all these are vulnerabilities, and this is why guardrails should be implemented using compliance policy to enable everything the agent is doing is audited. Mitigation include least privilege. Okay, so how can you mitigate against these vulnerabilities? So use least privilege, role-based access control, content filtering, either input or output, continuous evaluation, continuously monitoring, and human oversight. Very, very important. So put human in the loop where it is necessary. Let agent escalate to human when they need to escalate. Then review every solution for fairness, reliability, and safety. Every solution, every workflow, every step of the agent should be reviewed for fairness, reliability, and safety, and privacy and security, privacy and security, inclusiveness, transparency, and accountability. So every pillar of responsible AI must be implemented in the agentic system design, in development, in deployment, and in operation. Okay, so the next thing we have here is compliance. So compliance, under compliance, we have validate data residency, movement compliance. So where should be the data be residence, and how should the agent be moved from one domain to another domain, and operation and access, everything should be validated to compliance. And compliance uses company policies or Azure policies. So region determination using Azure policy or company policy, prompt processing, embeddings, connectors, and purview for general governance. Very, very important. Azure monitor for monitoring. So let's look at the point one after the other. Architects must know where prompts are processed, where models run, where logs, telemetry, backups, embeddings are stored, and where data moves. Very, very important. You are not just designing, you know where everything, every information in the system are located. Very, very important. Document data flows across Copilot, Azure AI Search, Azure OpenAI, SQL database, storage like blob storage, SharePoint, or OneDrive, connectors, and response generation. So agentic AI system data should not be stored anyhow in any platform, and even when they are connected to knowledge sources or or strange or unapproved platform should not be allowed. Also validate Copilot Studio conversation storage, connector movement, and preview feature residency behavior. Very important. Also use Microsoft Purview for data classification, cataloging, sensitivity labels, data loss prevention, compliance reporting, and audit logs. Very, very important. So Microsoft Purview is the governance layer or that you can easily adopt here to govern the entire information of the agent. Then restrict cross-region traffic and keep backup in compliant region. Always restrict cross-region traffic and keep backup in compliant regions. Keep agent data in compliant region. Deploy agent in compliant regions. Okay. The next thing we have here is grounding controls. So access control for grounding data and model tuning. So remember the fact that the agent should have access to knowledge sources does not mean that they should have any access or they should have unpermitted access. Then these are architecture terms that you should understand here. We have policy check, sanitization, search index, fine tuning, and role-based access control changes. So let's look at them one after the other. Grounding data must be authorized, trustworthy, petitioned by domain, and logged for auditability. Very important. Source retrieval flow. So this is how retrieval flow. We've looked at the architecture of a retrieval augmented generation, RAG, before. So but let's just walk through again. So we start with prompt, policy check, search index, sanitization, LLM context, and response. So this is the flow of how the agent retrieve information from the knowledge source from prompt to response. Then we have policy check. Policy check enforce authorization before retrieval. Sanitization remove unsafe or sensitive content from it before it reaches the model. So very, very important. Policy always check authorization before retrieval. Sanitization, just like you are cleaning something. Sanitization remove unsafe information and like unsafe information such as PII information or information that are sensitive, like PII information before it reaches the model. So the model only have access to what is accessible. So that is guardrail implementation. Then fine-tuning requires protected training data. Okay, so you need protected training data, accurate information to fine-tune the model. Fine-tuning also require evaluation data sets, tuned models, hyperparameters, environment separation, approval workflow, continuous monitoring. Very, very important. So know these requirements. So these are part of the examination. So make sure you you are grounded in this part, this fine-tuning requirement. So also monitor retrieval frequency, unusual searches, unauthorized access, tuning activity, and role-based access control changes. So when the role of the agent changes, make sure everything is monitored and observed. Okay, on this next slide, we have auditability. So auditability is, checking the entire application lifecycle management processes, whether everything the agent is doing, every implementation, every process, abide or is guarded by company policies, by Azure policies. Everything is properly governed using Microsoft Purview, using monitored using Azure Monitor. Telemetry data are collected using application insight are properly used, to mitigate risk. And the purpose of the design is to generate return on investment (ROI), or cost reduction by reducing cost and secure adoption. So which is risk mitigation and control. So the first thing we have, the architecture terms here that you should understand is correlation ID. Correlation allow you to trace error to the root cause. It allows you to trace what's happened in the system to what causes, the error. So there you can use a tracing UI for this, or application use insight metric for this. So correlation ID is very, very important. It traces, allow you to trace agents to a task, allow you to trace task to a connector, or trace an action to a connector, and so on and so forth. So we have model version. It's very, very important. Version your base model to cause. So it's a part of the architecture terms that you should audit it. Two calls should be audited. Our agent calls too should be audited. Sentinel can be used as the auditing platform. Sentinel is the general platform for auditing and the security operation on Azure, and Microsoft Purview for governance. So let's check them one after the other. Audit trails answer who, what, when, where, and why for important AI activity. So audit trail can answer all of these questions, all of these observability questions. Audit trails answer them. So model events to audit include all the model events that you need to audit include registration, that's agent registration, new versions, fine-tuning, evaluations, deployment, rollback, scaling, configuration changes, and unauthorized access. So all this should be, audited. Everything here should be audited, and many more of them that I will not even mention. So data events include injection, schema changes, refreshes, sensitivity label changes, sanitization, cross-region movement, and access approvals. So all these data events too should be mentioned, should be audited. Then log metadata rather than sensitive content. Always make sure you log metadata instead of sensitive content, and include correlation ID. Okay, very, very important. Correlation ID, we've said it several times, very important for tracing error to the root cause and to know which agent is causing the error, and how to, or fine tune the error and resolve the problem. So also make sure include correlation ID, model version, timestamp, prompt category, response time, tool calls, and safety results as part of your log. So export diagnosis log to Azure Monitor, Log Analytic Workspace, Microsoft Sentinel, Microsoft Purview for security and compliance check. So all this platform will enable you to use all your log for all your log to check whether the agent is abiding by the its compliance with the company policy, Azure policy, and implementing under the predefined and governed guardrail. So deployable agentic AI must be observable, tested, versioned, secure, compliant, and auditable end to end. So by doing this, you know that you are building a reliable agentic AI system that can be deployed securely end to end, either in Dynamic 365 or Office 365 environment. All right, guys. So this is the end of this lesson. Thank you for seeing us through. Thank you for following us from beginning, from domain 1, domain 2 to domain 3. And then if you're going to write the examination, I wish you all the best. And then in your solution, agentic AI business solution architect journey, I wish you all the best.